Hello, welcome to another episode of Physics is Easy with Mr. Jesse. This tutorial aims to solve a problem related to flat mirrors. This is one of the problems that I have given in WebAssign. In a church choir loft, two parallel walls are 5.40 meters apart. The singers stand against the north wall, so we could illustrate the first two sentences in this manner, where we have here on the north wall our choir members or the singers. Now the two walls, the north and south wall, are separated by a distance of 5.40 meters. Moving on with the problem, the organist faces the south wall sitting 0.85 meters away from it. So if this is the organist, he is sitting 0.5 meters away from the south wall. This is our south wall here. South wall. So that she can see the choir, a flat mirror with a width of 0.600 is mounted on the south wall straight in front of the organist. So that is our mirror over there, 0.6 meters. What width of the north wall can she see? We have our hint. Draw a top view diagram to justify your answer. So we are illustrating this problem as if we are looking from the top. So what's going to happen here is that light rays coming from the top part of or from this part of the north wall would strike the mirror and gets reflected towards the eyes of the organist. Now, since this is a flat mirror we're dealing here, and we know that flat mirrors will produce virtual images, we will trace the reflected ray backwards, so behind the mirror. Then also, rays coming from this part here of the north wall would also strike the mirror and gets reflected towards the eyes of the organist, and again we would trace the reflected ray backwards. Then with these reflected rays, or with this reflected rays, we will be able to see the image, and it's gonna look something like this. From this illustration, we will be able to deduce the following. So remember that the distance of the object is just equal to the distance of the image. So since this is our object here, and the object is 5.40 meters away from the mirror, so therefore the image would also be 5.40 meters, or the distance of the image would also be 5.40 meters. We could also obtain here the distance of the image from the organist, so the distance of the image from the organist, and that is just equal to the sum of 0.85 and 5.40, which will be equal to 6.25 meters. Now, if we look at this diagram here, this triangle is actually a similar triangle with this bigger triangle, and they are similar because these angles here, the angles of the small triangle, are equal to the angles of the bigger triangle, and that makes them similar. And according to similar triangles, or according to the principle of similar triangles, the ratio of the sides of one triangle should be equal to the ratio of the sides of the other triangle. So for example, if we are going to look at the width of this image here, which we are going to call, say, y big, or y big, which is the width of the width of the image, so that's y big divided by the length of the bigger triangle, which we're going to call L big. And what would that be? The L big, or the length of the bigger triangle, which is this, it's just equal to 6.25 meters. That would be equal to the y small and the corresponding side of y small. So if this is our y big here, the corresponding side would be this. Let me just highlight it with a different color. So this is our y small over there. Okay. divided by the length of the small triangle. And the length of the small triangle is this. Just highlight it with a different color. This would be the length of the small triangle. So now let's substitute our values. We have y big, something that we don't know, and it is actually something that we need to solve for. That is our unknown. Divided by the L big, and our L big again is just 6.25 meters, is equal to y small. Our y small is this, 0.6 meters, divided by L small, which is just this value over here, 0.85 meters. We could just so easily solve for y big now by doing cross multiplications. We have 0.6 multiplied by 6.25 divided by 0.85, and that would give us y big is equal to 4.41 meters. And in fact, this is the width of the image that we can see, or the width of the north wall that we can see. Width of north wall. And that concludes this tutorial. Once again, physics is easy with Mr. Jesse.